Okay, we are going to start factoring trinomials, and when we were multiplying monomials into the parentheses, we were using the distributive property. Then when we started finding the greatest common factor and we started factoring those monomials from the polynomials, we were using the distributive property backwards, so we were having to think in reverse. That's exactly the same process that we're going to use here. Used to, this was your answer. I would give you two binomials and you would use the FOIL method and the distributive property, one and the same, and you would come up with a trinomial. Well, now I'm going to actually give you the trinomial and I want you to think backwards. I want you to factor this trinomial and actually give me the two sets of parentheses. What were the two binomials that when I use the FOIL method I get this trinomial? So we're going to think backwards. And this is a fairly simple concept. So let's look at this first example. Let's factor this trinomial.
What is an easy way to organize your factoring?
Now this is a really good practice. This is a good way to get started with these trinomials.
Use the table to list the pairs of factors of the constant term c and the sums of those pairs of factors.
Now that might sound a little confusing, but what they want you to do is list all of the numbers that when you multiply you get 15. Okay, there's not very many of them. And then take those numbers and add them together. So for example, 1 times 15 gives you 15. 1 plus 15 gives you 16. So that's the type of table that they're asking you to make.
List the pairs of factors of 15. Identify the pair that has a sum of 8. Use a table to organize the factor pairs. The pairs of factors of 15 are 1 and 15 and 3 and 5. 1 and 15 add to 16, and 3 and 5 add to 8. Since 3 and 5 have a sum of 8, use that pair of factors. So x squared plus 8 times x plus 15 can be factored into the quantity x plus 3 times the quantity x plus 5. Check your factors by multiplying them together.
Basically, all you're going to do at this point is use the FOIL method. Okay? You should know that 3 times 5 is 15 and 3 plus 5 is 8. That's the two things that you're doing here in this table. So you should get the 8 and the 15. What you want to make sure of is that you have them in the correct places and that when you multiply your x's, you get x squared and so forth. So let's use the FOIL method. And that's another thing. That's the reason why we broke x squared into x and x. Coefficient of 1, that's what makes these a lot easier. When you do x times x, you get x squared, so that's one of the reasons we broke those. So let's do the FOIL method. Those are your first terms. Those are your outer terms. And notice we're just using the FOIL method. Inner terms, or distributive property. And your last terms. And whenever you actually simplify that, 5x plus 3x, you get 8x.
Since this matches the original trinomial, these factors are correct. Now it's your turn.
Alright, so I want you to try this one. I want you to list all the factors of 24 and then out beside those factors, list what their sums are and find the one pair that will equal 11. So that's what you need in the middle. Now, I'm not going to put the answer choices up there because I don't want you to be using the FOIL method for all the answer choices and finding the one that works. I want you to actually factor this out. If you need more time, pause the video, but your correct answer for this is r plus 8 and r plus 3. This means that 8 times 3 is 24, which it is, and 8 plus 3 is 11. Now, to look at the solutions to this, or the way that they came up with this, they listed all the factors of 24 just out to the side like this. And then if you start adding these, that's 10, that's 11, that's 14, that's 25. So the only pair that works is the 3 and the 8. All right, so let's look at another example. This one's dealing with negatives, so this is starting to get a little more difficult. If you notice, we want the factors of 24 here. When we add, we get negative 11. So one of the first things you have to ask yourself whenever you are facing a trinomial like this is, how can I multiply and get a positive number, but use those same numbers when adding and get a negative? Okay, so this is where you've got to think about what are your negative and positive integer rules whenever multiplying. Now, you're going to have to think about negative factors. Why look at pairs of negative factors of 24? Well, you have to look at the negative factors because that's the only way to get a sum of negative 11. Two negative numbers have a positive product. Remember, negative times a negative is a positive. And when you add two negative numbers, you're going to get another negative number. So you could list all of the positive factors of 24 if you wanted to, but you're not ever going to get a negative sum. So you have to go to the negative factors of 24. And notice this is exactly like the last problem you just did, except we are dealing with a negative 11, so that makes our 3 and our 8 both negative. So negative 8 and negative 3 work, which indicates that you have subtraction in your binomial, x minus 3 and x minus 8. And you can use the FOIL method like they did to check your answer. That's always good practice just to make sure that you have the correct binomials. And you do get the same trinomial that you started with. So x minus 3 and x minus 8 are the two binomials. All right, so now I want you to look at one. Same thing, you've got a positive product. What two numbers can I multiply to get a positive 8? But when I add, I get a negative 6. All right, so pause the video if you need some time. I'm not putting the answer choices up there because I want you to actually work this out, but your correct answer for this, making sure that your signs are correct as far as where they're located, y minus 2 and y minus 4, both of them will be negative. Negative 2 times negative 4 is a positive 8, and negative 2 plus negative 4 is a negative 6. And here they did list all the positive factors of 8 and the negative factors of 8, but only the negative 2 and negative 4 work for the sum of negative 6. So there's your solution. All right, so let's look at another example.
In this problem, you will factor a trinomial of the form x squared plus b times x plus c, where c is less than 0. What is the factored form of x squared plus 2 times x minus 15?
So we're just looking, this one's a little bit different than the last one because now our product has to be negative 15. So think about what are the two numbers going to have to look like so that I get a negative 15 when multiplying, but then when I add those two numbers, I have to get a positive 2.
Identify the pair of factors of negative 15 that has a sum of 2. Use a table to organize the factor pairs.
All right, so we're going to list all the factors of negative 15 here and add those factors to get their sum.
The pairs of factors of negative 15 are 1 and negative 15, negative 1 and 15, 3 and negative 5, and negative 3 and 5.
Now notice that these are the same. We're using 1 and 15 twice. We're using 3 and 5 twice, but the difference is where the negative sign is located. The first set here, it's negative 15. The second set, it's a negative 1. So you do have to try all of those possibilities in order to find the correct sum.
The sum of 1 and negative 15 is negative 14. The sum of negative 1 and 15 is 14. The sum of 3 and negative 5 is negative 2. And the sum of negative 3 and 5 is 2. Since negative 3 and 5 have a sum of 2, use that pair of factors. So the factored form of x squared plus 2 times x minus 15 is the quantity x minus 3 times the quantity x plus 5.
Now notice this is very important because if you use a positive 3, if you put a plus sign here and a negative sign in front of the 5, a subtraction sign, you're going to get negative 2. So you have the right number but the wrong sign. So you have to be very careful that you use the correct sign with the number that you've chosen for your factors. So always be very careful when you set that up.
What's another way to do this problem? Find two positive factors of 15 that differ by 2. The factors are 3 and 5. Then attach a negative sign to one of the factors so that their sum is positive. You get negative 3 and positive 5.
Now, the reason why they're suggesting another way to do this is because listing the factors of a negative number could potentially get very lengthy, okay, depending on what the number is. So if you start just trying to use your multiplication facts and think of numbers that are very close together within 2 of each other, so it differs by 2, like 3 and 5 do, then you can figure out which one should be negative and which one should be positive so that when I add, I get a positive solution. So this is just trying to give you a faster way to solve this rather than writing out the table. All right, so now it's your turn.
Now it's your turn.
And I want you to factor this. Now you've got a negative 36 as your product. You've got what numbers can I multiply to get a negative 36? But when I add those, I have to get a positive 9. So write out those factors. Pause the video so you have enough time to solve this. Make sure that your signs, the two numbers that you've picked, your signs are in the correct spot. Otherwise, you'll miss this just because you've got a negative sign where a positive sign should be. But your correct answer for this is n plus 12 and n minus 3. So like I said, it's very important where the plus sign and the subtraction sign are located. Now, if you are to write out every one of the factors of negative 36, it's going to get kind of lengthy. So here's a list of all the factors of negative 36. And notice we had to try all different sorts. We had to do negative 4 and 9. We had to do negative 9 and 4. So you have to try all the different possibilities. And the only one that gives you a sum of a positive 9 is when 3 is negative and 12 is positive. And notice that 12 and 3 are within 9 of each other. Like the example suggested last was another way to solve that is think of numbers that are within 9 of each other and then figure out which one's going to be negative and which one's going to be positive. In this case, it's a positive 12 and a negative 3. All right, so let's look at one more example.
In this problem, you will apply the process of factoring trinomials. The area of a rectangle is given by the trinomial x squared minus 2 times x minus 35. What are the possible dimensions of the rectangle? Use factoring. What do you know? You know the area of the rectangle. What do you need? You need the possible dimensions of the rectangle. So what's your plan? Area equals length times width. So factor the trinomial for area as the product of binomials that represent the length and width. To factor x squared minus 2 times x minus 35, identify the pair of factors of negative 35 that has a sum of negative 2. Use a table to organize the factor pairs. The pairs of factors of negative 35 are 1 and negative 35, negative 1 and 35, 5 and negative 7, and negative 5 and 7. 1 and negative 35 add to negative 34. Negative 1 and 35 add to 34. 5 and negative 7 add to negative 2. And negative 5 and 7 add to 2. Since 5 and negative 7 have a sum of negative 2, use that pair of factors. So x squared minus 2 times x